All right, good morning, everybody. Thanks for joining. So let's start with the basics. If everybody could please mute their phones or connections during the presentation, that would help me out a lot. And next, if you have any questions during the presentation, please save them till the end. I'm going to give everyone an opportunity to ask them then. So this isn't going to be a terribly long presentation. The topic today is connecting a PPC4000 or PPC6000 to a flame safeguard. So let's start with the basics. What is the difference between a PPC4000 or PPC6000 and say an NXF4000 or an NX6100? So all of the systems mentioned above are parallel positioning systems. However, you can further break down the functionality to the two primary duties they have: burner management or BMS and combustion control or CCS. The NXF4000 and the NX6100 handle both of the duties, meaning they can both establish and control the flame, such as a flame safeguard would do, as well as manage the parallel positioning of the servos. The PPC4000 and the PPC6000 only handle the parallel positioning portion, which leaves the burner management to an external flame safeguard. So why would you want an external flame safeguard? Well, while the NXF4000 and NX6100 can fit most applications, there may be times when an external flame safeguard may be a better solution. And some of those reasons would be the flame safeguard may offer additional features such as expanded enunciation or custom timings that the NXF4000 or NX6100 can't cover. Also could be retrofitting of a different parallel positioning system in that it already had an external flame safeguard and it would be simpler to just replace the parallel positioning system. The flame safeguard may offer different flame scanning options. Or lastly, you might just have user preference. The user may just want them to be separated. So how does it work? How does the PPC4000 or PPC6000 appear to the flame safeguard? Well, the flame safeguard was originally intended to control some kind of linear actuator or modulating motor. The actuator will take signals from the flame safeguard to go to the minimum or low fire position, the maximum or high fire position, or to be an auto, which is free to modulate. And in turn, the actuator then is going to relay back to the flame safeguard if the commanded position has been reached. That would be, for example, when you're purging to prove that you're open, or when you go to the ignition position to prove that you're closed. The closed loop design provides safety to make sure that the actuator is doing what the flame safeguard needs it to do. Once an auto, an external controller, such as a PID controller, can modulate the actuator to maintain the set point. The PPC4000 or PPC6000 connect to these same inputs and reply to the same outputs to appear to the flame safeguard as if they are a standard linear actuator. So an easy way to understand this is that to realize that in a standard burner bill of materials, an entire PPC4000 or PPC6000 parallel positioning system really just replaces one standard linear actuator. So how does the standard linear actuator work? The standard linear actuator has a single shaft that moves in a linear relation to the control signal. In theory, if the command is 4 milliamps or 0 ohms, it will be at low fire. 12 milliamps or 67.5 ohms, it would be 50%. And at 20 ohms or 100 or 20 milliamps or 135 ohms, it would be at high fire. So all of the different shafts and valves are driven off of this shaft. All the different dampers and valves are driven off of this shaft. The low and high fire positions can be set, but the curve between the positions will be a direct line or some kind of an arc based on the dynamics of the linkage. With a few exceptions, there is no real way to optimize the positions at any point in between, with the result being that most of the modulating range will be inefficient, having too much excess air. Additionally, having multiple fuels can be difficult since there is no way to change any of the parameters per fuel. They all have to light off at the same air position, meaning at least one of the fuels has a low fire that is going to be higher than it needs to be. So how does the PPC4000 or 6000 improve this? With the PPC4000 or PPC6000, every individual damper and valve can be controlled by a dedicated servo with feedback. Additionally, up to 2 VFDs can also be added as channels, provided that feedback is available from the VFDs. So this allows each damper, valve, and VFD speed to be set for each position, from purge, ignition, and throughout the automatic firing range. Each fuel can also have a unique curve, meaning that the ignition position of one fuel doesn't affect the ignition and low fire position of any of the others. So once commissioning the automatic operation curve, up to 20 unique combustion points can be programmed, which means that the combustion can be optimized for every 5% of modulation. This has the potential to greatly improve the efficiency over a standard linear actuator. So the connections from the flame safeguard to the actuator. So for a flame safeguard to be compatible, it must provide one and only one of 3 command outputs to the actuator at all times. These outputs must share a common terminal that allows whatever input voltage to be switched through to the actuator. So 2 common flame safeguards used with actuators that match these requirements are the Burner Logix Y from FireEye and the Honeywell 7800L in particular. So here's some wiring diagrams for these showing the common terminal, the terminal for high, low, and auto going to the modulator. So for each of these flame safeguards, the same terminals are available. So the actuator connections to the flame safeguard. Once it is determined that the flame safeguard can provide the necessary outputs to the actuator, it must also be verified that it will expect feedback from these commands. So the Burner Logix Y and 7800L also meet those requirements. So the FireEye website offers the PPC4000 wiring application guide, which offers 48 different wiring diagrams to match the combination of devices and options for many applications. A similar document for the PPC6000 is also in the works, available soon, so check the website for updates on this and other new bulletins, application notes, etc. So here's an example, and we'll also show a little more in the upcoming slides, but here's an example of the first 6 showing you what in the matrix, what's available in that particular wiring diagram, what combination of components and options. So here's a video showing the website navigation. So you go to the Products tab, and then you scroll down and you'll find PPC4000 parallel positioning, and you'll click on that. And then down in the section for Service Guide, you'll find PPC4000 Wiring Application Guide. And at the beginning of this wiring application guide, it's going to have some instructions and just some notes about the different wiring diagrams and things to keep in mind, and how to configure some of the options as well. Then it's going to have the matrix that we just looked at, showing you all of the different options so you can find the proper wiring diagram for your application. And remember, the wiring diagrams are generic in nature, so there's something for you to use as a guide. And then the wiring diagrams are going to follow. So in wiring, this is how we start. So profile selection and starting sequence. So line voltage from the flame safeguard blower output goes through a fuel selection switch. Using the blower output ensures that the flame safeguard has initiated startup, and the profile selection input has the dual purpose of profile selection and starting the PPC4000 or PPC6000 sequence. So you can see here in this portion of the wiring, the voltage comes out from the blower output, goes through the fuel select switch to one of the fuel selection options. Next, we have position commands. For the PPC4000, line voltage is used for this, but for the PPC6000, it's an internally derived low voltage which is used. So for the PPC6000, you want to consult the bulletin for details on the wiring type and method required, because there are some things you have to follow for the wiring method, special cable to use. But all of the outputs to low, to high, to auto, they connect to the PPC4000 and 6000 from the flame safeguard. So the PPC4000 requires that at any given time, only one of the position terminals has voltage. There will be a lockout if either no terminal or more than one terminal has voltage. And this can be a common occurrence when first commissioning. You will run into this lockout. So in this particular case, E13, you'll get a lockout check wiring, and it'll tell you that there is voltage on more than one terminal, or E14 that tells you there is no voltage. So once all of the servos and VFDs reach their program positions for purge and ignition, feedback is provided for the flame safeguard. So the PPC4000 and 6000 each have terminals for this that go back to the flame safeguard's low feedback and high feedback terminals. And those terminals may have different names. So the PPC4000 and 6000 each tie into the recycle limit strings. This is so the on-off switch on the touchscreen or on the keypad, as well as the internal load control, can turn the flame safeguard on and off as needed. The PPC4000 uses a relay known as the OCRC relay. So it can be located at any point in the limit string. Although in the diagram I have here, I showed at the beginning, receiving line voltage and being at the start of the limit string. And the PPC6000 only provides the line voltage out, so it needs to be at the beginning of the recycle limit string. The PPC4000 and 6000 each tie into the safety limit string as well, and this is so that a lockout of the PPC4000 or 6000 will also cause a lockout of the flame safeguard. So each of these is a relay, so they can be placed at any point in the safety limit, and although in this diagram they are also shown receiving line voltage to be at the beginning of the safety limit string. So this is the complete wiring interface between the two. So it lists all the terminals that are common between the Honeywell and the Bernalogics. They each have terminals with the same functionality, but different terminal numbers. And the PPC4000, 6000 as well, different terminal numbers, but most of the terminals are the same. Now we're going to go through a sequence showing in red which terminals are activated so we can see what's going on. So here we're in standby. So in standby, you're going to have voltage to the low terminal. It's got to have voltage on one of the three terminals at all times, so it's going to be too low. And our limit string is going to be complete, or our safety limit string anyway is going to be complete. So this is going to be where we're at in standby. So next we're going to have move to purge. So the sequence has been started. Power comes through the blower output, goes through the fuel select switch, and chooses a profile selection. At which point the flame safeguard now wants the PPC to drive to high, so it sends a command to that. So now the recycle limits are also closed, safety limits are closed. So this is the display you're going to see. Move to purge, and the flame safeguard is going to say that it's waiting for the limit to be proven. So once the limit is proven, the voltages are all the same here, but now we have high feedback coming back to the flame safeguard. So we still have the signal to go to high, but now we have high feedback as well. The PPC is going to display purge. The flame safeguard is going to begin its purge and count down. When the purge is complete, we're going to want to move to ignition. So at this point, the flame safeguard has now changed the signal to tell it to drive to low. And there's no feedback right now, so it's moving to the ignition position. Once it gets to the ignition position, the only difference now is it has received feedback. The flame safeguard has received feedback from the PPC that it is at the low position. So it's still telling it to be at the low position, but now it's received feedback. So that means it is at the ignition point. So the PPC displays ignition, and now the flame safeguard goes through ignition and PTFI. So nothing changes between PTFI and MTFI. So from pilot to main, trial for ignition. But the signals are the same. It's still being commanded to the low position. It's still receiving low feedback. The flame safeguard is just going through its sequencing. The PPC, meanwhile, is still going to be at the ignition position. So now that MTFI is over and we're going to transition to auto, now we're going to switch the signal to auto from the flame safeguard to the PPC so that it knows it can modulate. There's no feedback in auto. Our limit string is still complete. Our safety limits are still complete. We still have power coming out from the blower output, obviously. So in auto, these are going to be the lines that have power. And then when you're complete and you go to post-purge, the recycle limit is now open. The signal is going to go back to low. Depending on how quick it happens, you may or may not register post-purge on the PPC, but it's going to drive the servos to the low position. It's going to shut down, then it's going to drive it to the standby position after that's complete. So here's a video showing that sequence. So let me play that. You can see both devices. So right now it's moving to the purge position. And then when it gets to the purge position, you'll see the NXF or the PPC display switch to saying purge, and you'll see the burner logic start to count down the purge. So it says purge. It's counting down the pre-purge. When it's done counting down the pre-purge, it's going to issue the command to drive to the ignition position. Okay, so now it says move to ignition as soon as that happens. And then as soon as this gets to the ignition position, it will begin ignition in PTFI. Okay, so now we're in the PTFI. It's going to establish that, prove the pilot, switch to main, MTFI, prove the main. Then it's going to switch to auto, and you'll see the PPC screens display auto as well. So right now I'm trying some of the other options that the Burner Logix has, and this is T21, which is a terminal for low fire hold. So if you apply that terminal, it's going to go to low fire, and it's going to send the PPC to low fire. And the next one we're going to check is revert to pilot, which is terminal 16 on this particular program, or the 138. So T16, the first thing it's going to do is drive the PPC to low fire. The PPC is going to hold there, and it's actually going to turn the main back off when it gets there and return to PTFI. The PPC is going to stay at the low fire position. Burner Logix is going to stay in PTFI or pilot, and then as soon as we release the revert to pilot, it's going to relight the main and then go back to auto. Meanwhile, the PPC will just have been at the low fire position the entire time. So that's one thing to keep in mind, is if you're going to use something like revert to pilot, you're going to want your ignition and your low fire positions to be the same, because it's going to have to be able to light back off there from the low fire position. And that's just an option you can choose to use if your Flame Safeguard supports it. So now it's going to post-purge. It's been shut off, and it should end up at standby when the post-purge is complete. All right, so this last video here is just a little bit about how we commission it. So it's going to be going through the same steps, except that instead of going through the sequence, it obviously pauses for you to set the positions as you go. So first we start by putting in the commissioning passcode. Now we're in the standby position, so we're going to set the positions. Now this has already been commissioned, so I just kind of walking through pre-established positions. So we set the standby and we hit next, and it moves to position 1, which is going to be the purge position. Now the handshaking between the two is going to wait until we move through our commissioning process. So it's not going to send any feedback until we actually, or any commands until we actually set the position we want it to go to. So right now we're going to set the purge position. So it's going to be with the air damper open to, looks like 90 degrees. Then when I hit next, it's then going to actually begin the purge and send the feedback and begin the purge. So it's going to go through the purge like it did before, and then it's going to send the command to drive to the ignition position, and that's when we have to set the ignition position. So the Flame Safeguard doesn't really know what's going on. It's still sending and receiving the right commands. We're just delaying when we send the feedback until we've finished setting up the position we're trying to set. So now it went to point 2, and now we set the ignition position. So first it's driving down to where it was already set for, so that I can then tune it. When it's done moving, I'll have a star next to P2 indicating that I can set it. So now I would make any adjustments, except I'll leave it the way it is, and I'll hit next, and then it'll actually proceed with ignition. So now we're in PTFI, And it'll go through PTFI and it'll go to MTFI just like before. And we're at the ignition position, 0.2. So now it's in auto, and now it wants us to verify 0.2 again, which is a little different than an NXF, but that's because with like revert to pilot, like I said, you could light off at that same position. But then it went to 0.3, so I set and applied 0.3. Now I can do 0.4, etc. for as many points as you want to set for your curve. And then when you're done, you hit C mode so that it knows you've set enough points. If you want to add another, you hit next. Like I said, this was already commissioned, so I had points in it. So I was just walking through them, which is nice for when you lose your load during setup. All the points that you've saved, it'll go to that position the next time you start it up. You just have to confirm that they're where you want them to be. So this was just a curve for some kind of training. So now that it's done, I hit C mode and it's in auto. Now you don't have to turn it back off and on or anything. It's ready to go. Shut it down, move to low fire, and shut down just like normal. So we're back at standby. So that's it. So hopefully you guys learned a little from that and can see that how easy the interface is. It's really quite simple, the interface between the Flame Safeguard and the PPC, as well as commissioning it is very easy as well. So if anybody has any questions, you can type in the chat that you have a question, and then you can ask it, or you can type the question in the chat. If you guys don't have any questions, thanks for joining, and I'll see you next week.